Good morning, everyone. I am Dr. Deepak Singh, working as a senior scientist in Land and Water Management Engineering at ICAR-Indian Institute of Soil and Water Conservation Research Center, Datia. Today, I am going to talk about loose boulder check dams, a very simple but highly effective solutions for soil and water conservation. You might have seen them during field visits, small stone structures built across gullies. They may look modest, but they play a crucial role in protecting land, reducing erosion, and improving water availability. In next 20 minutes, I will take you through the problem they address, what exactly they are, how they are designed and constructed, their benefits and limitations, and why they are so important in sustainable watershed management. In many regions, especially hilly and semi-arid regions, heavy rain causes fast runoff. Water rushes down the slopes with great force, acting deep gullies into the soil. This leads to loss the fertile topsoil, which is farmer most valuable resources. Crops get damaged, fields lose productivity, and eroded soil end up as a silt in the river and reservoirs. Over time, land became barren, water table falls, and community suffers. To stop this chain of damage, we need structures that can slow down runoff, trap the soil, and give a land a chance to heal. This is where loose boulder check dam comes in. So, what exactly is a loose boulder check dam? It is a small structure, usually temporary, built across a gully or a small stream using locally available stones. The stones are arranged carefully without using cement or mortar. The idea is simple: slow down the water, reduce its erosive force, allow sediment to settle, and help more water soak into the ground. In doing so, the dam protects the land while also recharging groundwater. These structures are important because they deliver multiple benefits at the same time. They reduce the speed of flowing water, which means gullies stop deepening and widening. The soil carried by water gets deposited behind the dam, gradually filled up the gully bed. This traps soil along with increasing moisture, creates good conditions for vegetation to grow. Groundwater recharge improves, nearby well may hold water longer and crop productivity increases. Another great advantage is that they are inexpensive. No costly material are needed. They are built with local stones, local labors, and basic tools. Community can participate directly, which means a sense of ownership is created. Once constructed, the benefits are visible quickly. Farmers see their fields retaining more soil and moisture within a season. Of course, every technology has its limitations, and loose boulder check dam are no exception. They are not suitable for very large catchments or for a stream with very high discharge. They work best where the catchment area is up to about less than 50 hectares and where gully slope is less than 10%. They also need maintenance if stone get displaced or if too much silt accumulated. The structure loses its effectiveness. And in case of unusually heavy flood, the structures may get damaged. So while they are very useful, they are not a one size fits of all solutions. They must be planned and placed carefully. Site selection is the first and most crucial step. If we select a gully that is too wide or with very steep bank, the structures may fail quickly. But if we place it in a small stable channel with a moderate slope and check dam perform effectively. Priority should be given to gullies causing maximum soil loss near field so that the structures directly support agriculture. A wrong side at this stage can make the whole effort ineffective. Now let's discuss the key criteria of site selection. First, the catchment area should not exceed 50 hectares. Otherwise, the runoff volume will be too large for these small structures. Second, the gully bed slope must be less than 10% so that the water flow is manageable. Third, the foundation should be firm, rocky or compacted soil is ideal, while loose soil must be avoided. Finally, availability of good size stone nearby is essential as it reduces cost and effort during the construction. Once the site is chosen, we move on to the design. A loose boulder check dam must follow some basic design principle to be safe and effective. The height should not exceed 1 meter. Any higher and the risk of collapse increases. The top width is usually kept between 0.6 to 8 meter. The base width should be about 1.5 meter, giving it enough width to resist sliding. Both upstream and downstream face are sloped at about 1:1 or 45 degrees so that water pressure is distributed safely. In the middle, we create a spillway that is lower than the sides. This ensures that during high flow water always flow over the center and not from the edges, which could cause flanking. At the downstream toe, we add a stone apron about 1.5 times the height of the dam. This apron prevents scoring and undercutting. The large stones are always placed at the base and along the edges. Medium stones is in the middle, and smaller stones are used to fill the gaps. No mortar is required, just tight hands packing. Now these are the steps for constructions of loose boulder check dam. Let me now explain the construction process step by step. Here you can see the first steps in constructing a loose boulder check dam. The workers are collecting large stones from nearby area, and this is important because using local available stones are not only reduce cost but also ensure the structures blend well with the natural surroundings. Large stones form the foundation and base of the check dam, which give the strength and stability. And without a stone base, the dam would not stand with the pressure of flowing water. So collecting and placing these heavy stones properly is the most crucial starting points in this construction process. In next step, you can see the excavation of a trench across the gully. This trench is dug to a depth of about 50 centimeter and run perpendicularly to the gully bed from one side of the bank to the others. And the trench forms foundation of the check dam. Here we can see across the gully. We can here the 50 centimeter depth of the gully across the gully bed has created, and it's anchor the stone firmly into the ground and prevent the structures from being washed away during high runoff. Without this trench, the dam would be unstable. So preparing a strong foundation is just important as collecting stones. After a trench is prepared, the next step is to place large stones at the base. As you can see in this image, the bigger stones are tightly packed inside the trench. These large stones form the foundation layer of the check dam. Their weight and size provides stability and preventing the structures from shifting under the force of water. This base layer is critical because it ensures the durability and strength of the entire dams. Once the large stones are firmly placed at the base, the next step is to add a successive layer of smaller stones as shown in this image. The stones are arranged neatly one layer after another until the structure reaches the desired height of about 60 to 80 centimeters. Using progressively smaller stones help fill the gaps and lock the larger one in place. This arrangement gives the dam strength, stability, and prevent water from creating weak points. The gradual layering ensures that the structures can withstand the force of flowing water. After the dam has raised with successive stones layers, it is important to provide a spillway and a downstream approach. As you can see in this image, the central spillway is kept slightly lower than the side wall. This allows excess water to safely pass through the center without overtopping. The structure just below the spillway, a downstream apron made of stone is laid. The apron absorbs the energy of falling water and prevent scoring at the base of the dam. Together, the spillway and apron protect the dam from damage during the heavy flow and ensure its a long-term stability. One dam alone has limited effect. That's why these structures are normally built in a series along the length of a gully. Each dam slows down the water and collects sediments, and next one downstream continues the process. The spacing between them is calculated so that the toes of one dam coincide with the top level of the next. In this way, the entire gully is treated and the soil erosion is controlled throughout the drainage line. This series effect is one of the strongest aspects of the Luj Boulder check dam. Construction is only half the story. Maintenance is equally important. After every rainy season, the structures should be inspected. If stones are displayed, they must be ragged. If sediment has accumulated up to the half of the dam height, it should be removed. Any sign of flanking or undercutting should be corrected quickly. Vegetation should be encouraged on the bank and around the structures as root help binding the soil. With such regular care, a Luj Boulder check dam can last for many years and continue give benefits. To sum up, Luj Boulder check dams are small, low-cost, eco-friendly structures that play an important role in soil and water conservation. They reduce runoff velocity, trap sediments, recharge groundwater, and support vegetations. Their design is simple, construction is easy, and community can take part directly. They are not suitable anywhere, but where conditions are right, they can transform the landscape. These structures remind us that sometimes a small intervention brings big results. By placing stones in the right way, we can save soil, store water, secure livelihoods. Luj Boulder check dams are therefore a cornerstones of sustainable watershed management. Thank you for your attention. I hope this session has helped you clearly understanding what Luj Boulder check dams are, how they are built, and why they are important.